So Pythagorean Theorem states in a right triangle, if you talk, I will have you leave the room. In a right triangle, the sum of the squares of the lengths of the legs, they call these the legs, they're the two sides at the right angle, is equal to the square of the length of the hypotenuse, and that's that very long side. Hypotenuse is always the longest side on the right triangle. So it says a squared plus b squared equals c squared. Let's look at this in a way that makes a little more sense for you guys typing in calculators. What I want you to do is think about this. We did functions, so if we've got an equation, we can rewrite that equation any way we desire, correct? Uh-huh. So what's the inverse function of a square?
Square root.
A square root, very good. So c squared equals a squared plus b squared. We got that right, that's just the same thing. If I square root both sides, what number times itself is c squared? C times c, right? So c times c is c squared, right? So the square root of c squared is c. So c equals the square root of a squared plus b squared. So now you're literally at the point where you can type this straight in the calculator.
Just the little line thing, a to the second power plus b to the second power.
Mm-hmm. They call that a radical sign.
Is that a radical sign? A squared plus b squared.
Yep, and that equals c. Now let's take it. Why is it every time I start speaking, Christian, you start speaking?
I wasn't talking at all.
Oh, somebody was over here.
It wasn't me.
Okay. We could also take that. Now, that's assuming that we know the length of the legs, which is actually pretty common. Think about this. If you're building a roof, you know how long the roof is and how tall the roof is, right? But it's very hard to tell the slant of the roof. So if you know the height and the width, you can take a squared plus b squared, and that equals c squared, which is the length of the roof. So it's used in construction all the time. Mary, you're looking at this. Look at this. Picture a roof.
No, I understand.
You understand it? Okay, I thought I was confusing you. So that's used all the time to find out how much wood do I need here.
How much wood do you use?
Now, here's the deal. What if I don't know what A is? By tradition, A is the shortest leg of a right triangle. I will tell you, honestly, it doesn't matter, but it drives mathematicians nuts when I put A on the long leg. It stresses them out and causes them confusion because the formulas all work the same. My brain works like that. So let's say I don't know what A squared is. If I don't know, can I find out what A squared is? How would I do that? If I've got a squared plus b squared equals c squared, how do I know what a squared equals?
C minus b squared.
Think a squared plus b squared equals c squared, right? Now, if I want this b squared on the other side, what do I got to do to move it?
Divide.
Right now there's all addition, right?
Add the opposite.
What's the opposite of b squared? Negative b squared. That's the opposite. I'm adding the opposite, right? So I do it from both sides. I end up with a squared equals c squared minus b squared. I've just written the formula for one of the legs, haven't I? How do I get rid of the a squared? What's the radical sign, right? I radicalize both sides. What number, and remember a variable is a number, what number equals a squared? What number times itself is a squared?
1.
No, 1 times 1 is 1.
A. 1 times
A. A times A is what?
A.
A squared. So A equals the square root of c squared minus b squared. These two formulas will solve everything I need in a right triangle. One is the formula to find the hypotenuse, and one is the formula to find a leg. Isn't it?
That's easy.
Does that make sense?
It is. This is easy. This.
All right, focus, Araya. Yes, ma'am.
It makes sense, but do you think you could do one with numbers?
Sure, I will. I gotta find one. I'll do the first one when we get to homework, okay? So let's talk about the converse of the Pythagorean theorem, and that's actually a lesson coming up, so I won't belabor it. So the converse of the Pythagorean theorem states that if a squared plus b squared equals c squared, then it's a right triangle. So if I give you three numbers, and you put them in your calculator, if I give you the number, type this in your calculator.
Wait.
3 squared plus 4 squared equals 5 squared. 3 squared plus 4 squared equals 5 squared.
It's true. You're a true parent.
Wait, 3 squared
Plus 4 squared equals 5 squared.
How is that
false.
true?
3 squared plus 4 squared equals 5 squared. What'd you get?
25. Oh, wait.
You following along?
I don't know how to find the square button. It's
Okay, ask.
We didn't have calculator. It's the.
So, it says it's true, right? Type in 1 squared plus 2 squared equals 3 squared.
Wait, what?
1 squared plus 2 squared equals 3 squared. You need to be less rude. Which part of 3 plus 4, 3 squared plus 4 squared plus equals 5 squared was the hardest one?
Wait, what's the
Type in 1 squared plus 2 squared equals 3 squared.
Wait, can't you?
Type in 1 squared plus 2 squared equals, it's false, right? So, using the converse of the Pythagorean theorem, if they give me 3 sides, I can tell them if it's a right triangle. Right away. So that's that one, and that one's really an exercise in typing in the calculator. The distance formula, I'm going to hold for that day to talk about it because it's a little longer and a little confusing. So far, it's a little fuzzy. We're going to go into specific lessons. Today, we're going to focus on the Pythagorean theorem. Tomorrow, we'll focus on the converse, which is typing like we did. And Wednesday, we'll focus on the distance formula, which is just another way to write the Pythagorean theorem. Okay, any questions so far?
No, sir.
Good. I'll stop that recording and start.